faculty and scholarly impact in the medical sciences. And why did we choose to focus on the medical sciences? According to OECD data, women's and men's proportion of medical graduate students have been balanced since around the early 2000s. But what we know about women's representation at the full professor level, they continue to be underrepresented at levels of 21% and 23% in the US and Europe. And of course, we also see notable variations across medical specialties. Here's an image I came across at Stanford University's website a few years ago, and I think it does a great job at demonstrating just how gender segregated some areas of medical research continue to be. Here we can meet the staff and we can meet the faculty. And here we have a highly prestigious medical research area in a highly prestigious university, and the gender division of labor is quite obvious in this case. Why then are we interested in studying citation performance? There's of course some disagreement in the STS and information science literature as to whether citations represent meaningful proxies of performance. However, in the sociology of science at least, citations have often been conceived of as proxies and drivers of scholarly recognition and status. Merton, for instance, talk about citations as atoms of peer recognition. And the use of tenure or the use of citations in tenure hiring and funding decisions is also widespread, of course, mostly in the medical sciences and the natural sciences. And the question of whether a gender gap exists in these types of measures are therefore, I think, important to address. And the existing research on gender and citation performance is characterized, I would say, by notable variations depending on both methods, discipline, and study of research, you can say. However, in the most famous global study on the topic, which was published as a comment in Nature in 2013, it is stated that papers with female authors in key positions are cited less than those with male authors in key positions. And this comment has been heavily cited and widely shared on social media, and it uses bivariate comparisons of field normalized citation rates to kind of show group level gender differences of around 8 to 10% or so. And here would say that classifying women's and men's citation performance as distinctly different based on mean-based comparisons of millions of papers is misleading, at least for two reasons. First of all, I think it lends the impression that individual men and women in how it is formulated here it differs substantially in their per-paper citation rates. But this would be a misinterpretation, I would say, of the data, because indeed an average difference of 8% would, given the expected distribution of citation data as we see them, imply great deal of overlap for women and men. And here's a concrete example from our own data of what a log distribution of a 9% gender difference looks like in citation data. Much overlap, very little difference. Further, it's important here to mention that when we talk about these types of comparisons at the global level, there's a lot of confounders we need to take into account. Institutional affiliation, the ranking of institutions, influence, citation scores, the number of authors is very important, self-citations, and so on. And despite these limitations, many researchers have taken up these results from the Nature comment as hard evidence that women and men's citation rates are substantially different. Here are some recent examples of papers that cite the Nature comment to describe a link between gender and citation performance. And note here that many of these examples emphasize distinct between-group differences. So why then is it important not to exaggerate these average differences? Here I think it's important to remember that not everyone interprets possible gender differences in citation rates in the same way. Some researchers interpret this potential average gap as a concrete example of what we could call the Matilda effect here, alluding to the systematic under-recognition of women in research. And given extant social psych research on unconscious bias, I think this interpretation intuitively makes sense. However, there's a real danger that others may interpret the same results as evidence of what neurobiologist Ben Barres that worked here at Stanford has described as the Larry Summers hypothesis, that science gender gap is explained by a natural selection of the best and the brightest. And while this interpretation may appear less likely, or is less likely to appear on print, I think it may still resonate with some academics and research leaders. And that's easy to see if you start to look at people discussing stuff like this on the internet. There's a lot of people that are still convinced that these are kind of the explanations of stratification. So in our study of gender and, sorry, let me see. I went the wrong way, sorry. So in our study of gender and citation impact in medical research, we draw on a global sample of approximately 1.3 million research papers that were published from 2008 to 14. And we've used a name-to-gender assignment algorithm to disambiguate author gender based on first name and country affiliation. And there's all, of course, the challenge of some countries with the precision of this. We found 13 countries in Asia, Eastern Asia, and in Africa where it was imprecise. We removed them. So actually, we do not have an entirely global sample. But that kind of increased the precision of the rest of our sample. So our outcome variable in this study is field normalized citation scores. And it's a way to kind of adjust for field variations and allow for comparisons of citation performance irrespective of the year stuff was published. And for robustness text, we ran the same analysis with raw citation scores, reaching the similar results. So it doesn't really matter which of these approaches we choose here. We base our analysis on exact matching. That means that before we run regression analysis to kind of adjust for confounders, we match male and female authors on 3 variables that have been known kind of to boost citation rates. The first is institutional prestige, geographical region also, and medical specialty. And what we do then is to create 3 samples where we want to compare the citation rates of female first and last authors versus other combinations of first and last authors. We want to compare female last authors with first last authors, or with male last authors, and female first authors with male first authors. So it's an attempt to kind of level out some of the confounders based on a matched sample. And here is what the log distributions of per paper citation rates look for the matched set of male and female first authors in our sample. And again, I would argue that it makes more sense to think about this as indicating similarity and overlap rather than difference. And the same is the case if we look at the last authors, both female and male. Small variation and large overlap. Finally, if both the first and last authors are women, we see a slightly bigger difference here if we look at the curve on the right side of the curve. So what we did next was to kind of find a way to adjust for additional confounders. We ran generalized linear models with a Tweedy distribution. And this is a distribution that's useful for modeling highly right-skewed, non-integer continuous data with a probability mass at 0. And here we included 4 additional variables: journal impact factor, international collaboration, numbers of authors per paper, and self-citations, as some of the factors that we know, irrespective of gender, will usually boost a paper's likelihood of being cited. And here we have the results for our 3 comparisons, the 3 matched samples. And to just summarize shortly, it's the things highlighted in bold here is for comparing first authors, men and women, last authors, and the final set of both female first and last. Think here that the incidence ratios, which is the effects here, are the x-axis is very narrow, which implies that these effects are extremely close to 1, implying no discernible gender effect. And if we look more into kind of what explains the average difference in bivariate comparisons, it's self-citations. And here's perhaps important to mention that, okay, so self-citation can create some kind of stratification. But this effect was recently shown to be explained by a generational effect in science and in medical science, that there are more older men that cite more of their own papers. But if we start to take that into account, women and men cite as much their own work. There's not really a difference here as well. So my point here is that while citations appear to be a negligible factor in the perpetuation of gender inequalities in academic medicine, at least, the so-called productivity puzzle may still play an important role at the early career stages. And this is, I think, because we know from many other studies that this is where we start to see some stratification, especially due to, for instance, questions of career breaks in the early career, collaborative research where there may be differences. They may have to do with funding, likelihood of being funded, and how many people you have in your labs. And we cannot look into it here. We look at a cross-sectional perspective focusing on per paper. In order to study this, we need to look at it over time. Our only story here is that we need to, at least in medical research, move beyond thinking about citations as the stratifying factor here. That's not where we see an issue. It's not in visibility. It's not in how research is discussed. It's more a question, I think, at another level. And I think this point is demonstrated quite well in a recent study, which is my final slide here, from Canada, where they look at 24,000 applications for the Canadian Institute of National Health Research. And it's interesting because they had the opportunity to compare two programs. One program where reviewers were asked to focus on the past performance of the PI. Another program where they were asked to focus more specifically, forget about the PI's past performance, look at the quality of the research being done in the proposal or proposed. And here the interesting thing was there was a 30% difference in women and men's likelihood of winning grants when the focus was on past performance and on how many papers you have and so on. But if reviewers instead look for the quality, it leveled out. There are no difference anymore. And I think this varies, of course, also across disciplines, how much and how you understand excellence. But in medical research, it's at least one of the examples of the importance of thinking about evaluative regimes to some extent and how much emphasis we put on productivity when we kind of evaluate. And I think, therefore, a main point here is that discussions of stratification, at least in sociology of science, has very often focused on citation as an important matter. In academic medicine, I think we need to kind of move beyond it and think that, yes, there are issues around publication productivity, and we need to take these into account, but there are many other factors, and sometimes we focus too much on the wrong issues and forget to address kind of broader mechanisms of discrimination in the system. Thank you.